Wait a minute. Oh, hello. Hello and welcome back to Monty's Python Show. This is the 7th video in our series of tutorials on object-oriented programming in Python. In today's video, we are going to be learning about method resolution order and the diamond problem in Python. First, let's just define a few things. Method resolution order. What is that? So the method resolution order in Python refers to the order in which classes are considered during attribute and method lookup when you have multiple inheritance. The method resolution order in Python is determined using something called the C3 linearization algorithm. It creates a linear order of classes through which Python searches for methods and attributes. The algorithm follows the following strategy. It looks depth first, meaning it looks up the tree of ancestry in a class, and then it looks left to right when you have multiple inheritance. The idea behind the method resolution order is to maintain the consistency of attribute and method resolution when you have multiple inheritance, and it preserves the order of class hierarchy, ensuring that class and its ancestors come before their descendants in the linearization. And we're going to see an example of that in just a moment. Okay, let's go ahead and get started with our first program. I'm going to be using JupyterLab for today's programming, but feel free to use whichever development environment works best for you. So we're going to start off with a very simple program. We're going to create 3 classes, top, middle, and bottom, as follows. We've got a top class, and we're going to keep this simple just so we can demonstrate the concepts behind this. And we're going to have just a single class attributes in each class called level. And so our top class is going to have level set to top. And we're also going to pass. Then we have a middle class. Which also has a level attribute set equal to middle. And we're going to have a bottom class. And for now, our bottom class is going to inherit from middle. And I forgot to mention that the middle class should inherit from top. Okay, so there's our 3 classes. Let's go ahead and create an object, obj, of the bottom class. And let's access the level attribute. Okay, so we can see that we got a result here. It returned the string bottom, which comes from within the bottom class. Now, bottom inherits from middle. So if we were to comment out this line, level in the bottom class, and rerun our code, we'll now see that the string middle prints out as the value of the level attribute. And that's because bottom inherits from middle. And since it does not have its own attribute called level, it goes up 1 level to its superclass and returns middle. Now in the middle class, let's go ahead and highlight that and comment that out. So let's try that. Okay, so now bottom doesn't have the level attribute, neither does middle. So since middle inherits from top, it looks up into the top class and returns the level top. So you can see there pretty obviously the linearization that's happening, which is to go up through the classes first. Okay, so now let's go ahead and add a little twist in our code. Let's create a multiple inheritance at the level at the class bottom. So bottom is going to now inherit from top and middle. And let's go ahead and uncomment out the code. And let's run it and see what happens. So we got a type error, and Python says cannot create a consistent method resolution order for basis top, comma, middle. So we've created a conflict in our resolution order that Python cannot work out via its linearization algorithm. So what's going on here? Okay, so let's break down this code a little bit and see if we can understand what's happening. So if we look at our bottom class, we can see we have multiple inheritance. It's inheriting from top and middle. And top is the first class listed in its inheritance. And if you think about the order of inheritance, we go depth first and left to right. So starting with top, Python will search up through the family history, if you will. It's going to go directly to top. Okay? So here's the problem, is that by doing so, working vertically first from bottom to top, we've bypassed the middle class. And if you remember from our notes that the method resolution order in Python is set up to ensure that a class and its ancestors will always come before their descendants in the linearization. But in this case, middle, which is an ancestor of bottom, is actually pushed behind bottom in accessing top's attributes and methods. That is what's creating the error. So graphically speaking, we've got bottom inheriting from both top and middle inheriting from top. But since the order is depth first and then left to right, we've got this conflict because bottom is accessing top before middle. Middle is an ancestor class to bottom, and the linearization algorithm puts bottom's inheritance to top ahead of middle, and this is in conflict. Now we could fix this problem by simply changing the order of our inheritance in the bottom class. So let's change the order of these two classes. Let's inherit from middle first and then top. So we see that we got rid of the exception, the type error that was being raised by our code. But if you really think about what's happening here, this code really doesn't make any sense. There is no advantage to having a multiple inheritance, because if the level attribute did not exist at the bottom level, if I comment that out, you can see that the vertical first orientation of the linearization algorithm, it goes up to the middle first. So it moves up in the hierarchy first, and there it finds a level attribute, so it prints out middle. Now, if we did not have that attribute at the level of middle, and I run it again, it looks up one more level and finds it at the top. Now, if that attribute did not exist at the top, there is no added benefit to having bottom inherit from the top class, because the attribute doesn't exist anywhere in the hierarchy that you couldn't already get through the vertical search pattern. So the left to right doesn't add any new information in my class structure. So having bottom inherit from both middle and top doesn't add any functionality to the code, although it does get rid of the original error. We can accomplish the same thing just by our original code, where bottom inherits from middle, middle inherits from top. Okay, so we're going to extend our code a little bit, and we're going to add another class at the middle level, or we're going to change our existing middle class. So let's go ahead and change class middle to be called middle_left, and it will still inherit from top. And we're going to change the level attribute to say middle left. Now we're going to add a new class called middle right, and we are going to set that to also inherit from top, and it has a level attribute set equal to middle right. And we're going to change our bottom class to have multiple inheritances. So now we're introducing the possibility of creating a resolution conflict. So bottom is going to inherit both from middle left and middle right. Okay. So let's go ahead and run that code, and we can see when we run it the first time, since the bottom class has the attribute level available, it prints out bottom. So let's go ahead and comment that out and see what happens. Now, based on the linearization algorithm, we know that it goes depth first and then left to right. So depth first, left to right, you could probably predict the outcome. Middle left. So it went up one class, and it started with the class that is on the left, which is middle left. And so that is why middle left printed out. Now let's go ahead and comment out the middle left level attribute. And so let's think about this now. What do you think is going to print out now? Will it go up one more level? Will it search vertically? Or will it search left to right to find middle right? What do you think the outcome will be? If you said middle right, you are correct. And let's think about that for a second. If it went up vertically into the top class to access the level attribute, then that would be in violation of this idea that a class cannot access superclasses in its tree that are higher than its own ancestors. So if in this case it were to access the top level, it would be effectively bypassing the middle right sibling. And the middle right sibling is an ancestor of the bottom class. So the way the algorithm works is it will not allow the bottom class to access the top level class before it has looked in all of its ancestor trees that are lower in the ancestry than top. So that's why it goes into the middle right next. And remember, in our last block of code, we tried to write code where it accessed the top level before it's one of its ancestors, and that created an error. So the way the algorithm works is it will first go to the sibling class, the middle right, and look for the level attribute there. Now, if we go ahead and comment out the level in the middle right class and run it, now we can see, we get an error. I need a pass here. Forgot to write a pass in the middle right class. There we go. And so now we can access the level attribute at the top, so it prints out top. And you may be wondering, what was the path by which it got to the top? So the path that it got to the top, if you mapped out the search path in this case, it actually looked in bottom first, didn't find it, and then it looked in middle left, didn't find it, and then it looked in top and found it. It did not look in bottom and then middle right and then top. Okay, so we have seen that problems can arise when you have multiple inheritance. And in computer science in general, there is this problem known as the diamond problem. And the diamond problem arises when a class inherits from two or more classes that have a common ancestor. If you create your classes and your inheritance in such a way that violates the resolution order of the program, then you're going to get an error. Luckily, there is a way around this, and Python does a really good job with its algorithm to allow you to set up classes that have multiple inheritances with common ancestors and have your code still work, which we saw in our simple example, which we'll refer to as the diamond solution. And so in our diamond solution program that we created, where we had 4 classes, and the bottom class had a multiple inheritance from both middle left and middle right, and both middle left and middle right have a common ancestor, we saw that we can write our classes in such a way where the code works just fine and it resolves itself without error. So we saw that, for example, if the bottom class does not have a particular method or attribute that you're searching for, it will first, it searches vertically and left to right, right? So depth first, then left to right. So the middle left was our first specified parent class of bottom, so it searches there first. And if middle left does not have the attribute or method that you're searching for, it then goes left to right, so it searches in the middle right class. And then if the method or attribute did not exist in that class, it then goes back to the middle left and searches vertically again, where it finds the method or attribute in top. Or if it doesn't find it, then it would return a not found error. Now, how do we know that the algorithm actually goes back to the middle left and up to the top? Well, you can test this yourself by creating another class called top left and have top left be the parent class of middle left, and you will see that middle left will search up into top left. And that's how you'll know that the search algorithm actually went through the middle left class first and not the middle right. Okay, so that does it for this video in our series on object-oriented programming in Python. In our next video, we are going to explore inheritance versus what's known as the compositional style of creating Python classes. So stay tuned for that one. We'll see you next time.